Hi students, today I have come with a topic for class 9 that is based on simplifications and something which is very new for you all, that is logarithms. Logarithms came up just to solve the problem of lengthy calculations of numbers, like finding the fifth root of a number, seventh root of a number, or finding the power of a number like any number raised to the power 8 or raised to the power 25, like this, or huge numbers of multiplication and division based on decimals also. So to sort out those problems, logarithm came, but then after that calculators and computers came up, and that reduced the use of logarithms. But there are still many places where a lot of formulas in physics are based on logarithms. So that is why the knowledge of logarithm is essential for us. So we will be starting with the basic of logarithm. And we come across different mathematical operations which are one is the opposite of the other. Like for example, we know that division is the opposite of multiplication. Addition is the opposite of subtraction. Same way, logarithm is the opposite of exponent. So exponent and logarithm are opposite of each other. That is why I have started by writing the exponential form and then the logarithmic form. So we can relate how exponents get converted to logarithm in this way. In exponential form, you know that 7 to the power 2 will have a value 49. And this can get represented in log like this. This is the value, it will go for log of that number. Base is 7, it will go in the base of log itself. So log 49 to the base 7, whatever is the power here becomes the value of it. In this way, exponential expression is converted to logarithmic expression. Now, I have taken a general form where it is a to the power n is equals to b. Now converting it into the logarithmic form, log of b is written, this goes to the base of a, and then the power n becomes the value of that log. So we read this in this way, log b to the base a equals to n. So if I read it over here, log 49 to the base 7 equals to 2. Now using the general form, we can relate what type of values this a, b and n can have. This a will always have a positive value or a positive number, but it cannot have 1. Okay, except 1, it can take any positive number. Then this n which is there in the power can be any rational number. It can be positive, it can be negative. Okay. Then if a is positive, n is any rational number, whenever we simplify it, b value will always come as positive. So when we know that b will come as positive and take a look with the log form, what we notice here, it is a log of b. So log of b with any base, that b cannot be negative. You have to remember this, because when we do the sums, a lot of times such answers, this at the place of b will come, it can be positive, it can be negative. We will have to reject the negative value of it. So that you have to remember that log with negative, it will not come. Okay. So now let us take a look at one more number, okay, just to clear it, how the conversion takes place. So log, for example now, if I write here 9 to the power of 3, so you know the value will be 729. Now if I go to convert that into the log form, so log of 729, because this is the value, the base will be 9 and the value will be 3. So I will take few more sums whereby we can relate how the conversion from log to exponential form, and from exponential form to log can be done. Okay, so let us take some numbers from the question which is there. So for example, if I have to convert this number to logarithm, okay, like if I am taking here 3 to the power minus 2, okay, we know will come as 1 by 9. So when converted into the logarithm form, it will be log of 1 by 9. I'll put a bracket because there is a fraction part here, and the base will go as 3 and value will be minus 2. Okay, so same way we should know how to convert from the logarithm form to the exponential form also. So let us take a question where it is there in the logarithm form and we need to convert it into the exponential form. So I have written here log 81 to the base 3 is equal to 4. So now in the exponential form, this is the base of 3, so that will be written first. The value of that log will be written in the power and 81 goes over here. And you know 3 to the power 4 will give you 81. So this is the way to convert. Now the question will arise, what happens when with the log the numbers are not simple and we need to know the value of that log? Okay, so let us take a condition like that and deal with it. So for example, if you are asked to find the value of, I'm taking a number 1 here, and that is log, if I take 27 to the base 9, you are asked to find the value of this log 27 to the base 9. So what do you do then? So I will assume here first, let log 27 to the base 9 is equals to x. So now it means if I get the value of x, that will be the value of log 27 to the base 9. So I will change it from the logarithm form to the exponential form. So in that way, base remains as 9, the power comes as x, and this is 27. Now how to solve and get the value of x, we have learned in the indices part. Now you know 9 can be written as 3 to the power 2. So it becomes 3 to the power 2x, and 27 I can write as 3 to the power 3. So it means bases are same, so power should be equal. So 2x equals to 3. So you get x is equals to 3 by 2. It means I can write here now that log 27 to the base 9 will have a value of 3 by 2. So this is the value for log 27 to the base of 9. Now let us take one more number and deal with it. So if I am taking another sum here, second one for this, that is log 256 to the base of 0.5. So I need to know the value of this now. So let us simplify it in the same way. So it will come, I will write here, let log 256 to the base 0.5 is equals to x. Now 0.5 to the power x equals to 256. Now we know 0.5 is same as half. So I can write here half to the power x equals to, now 256 will be 2 to the power what? I suppose you all remember 2 to the power 4 is 16, and 16 into 16 is 256. So 2 to the power 4 2 times, I will get 2 to the power of 8. Now I can write here this is half. So I am leaving it as half to the power x. This side also the base should become half. So if I make 2 as half, you know that the power will have to be written in negative. So I have written it as minus 8. So now bases are same, so I can write x is equals to minus 8. So now log 256 to the base 0.5 will have a value of minus 8. So now you know if you are given any of these log values to find, by using them in the exponential form you can get the value of it. Now let us see how we are going to solve some of the equations given in logarithm. So I have already taken 3 sums and I will try to explain those 3 sums for you all to make it, you are able to understand it. So my first sum is log x to the base 9 is equals to 2.5. So as we have been doing it, so if I bring it into the exponential form, you know it will be written as 9 to the power 2.5 equals to x. So 9 to the power 2.5, so 9 can be written as 3 square, and then we have the power 2.5 is equals to x. So 2 into 2.5 will give you 3 to the power 5 is equals to x. 3 to the power 5 means 3 into 3 into 3 into 3 into 3. So if you are going to multiply it, okay, 3 3 is 9, 9 3 is 27, 27 3 is 81, and 81 if you multiply with 3 you will get 243. So we get here x is equals to 243. So it means log 243 to the base 9 will have a value of 2.5. So I suppose you have understood how to solve this. Now let us take the solution of this one, where it is told log x to the base root 7 is equals to 2. Again converting it in the exponential form. So you will get root 7 whole square is equals to x. Now you know if you do the square of any root number you get the number itself. So you get here therefore x is equals to 7. This becomes your answer. Okay, so that was a little bit shorter than this solving, but the concept used was the same. Now let us come to this sum. Now again we are going to write it in the exponential form. So 4 to the power 3 by 2 will be equals to 2x plus 3. So now 4 can be written as 2 square, and over that another power, so it will get multiplied, is equals to 2x plus 3. This 2 will get cancelled, so 2 to the power 3 is equals to 8 is equals to 2x plus 3. So now 3 I will bring it this side, so 8 minus 3 equals to 2x. So I will get 2x is equals to 8 minus 3 as 5, and then therefore x is equals to 5, 2 will go and divide, so I get the value of x as 5 by 2. I can write it as a mixed fraction, or I can also write it as a decimal 2.5. So I hope these 3 sums have taught you, made you understand how to work out sums where equations will be given in the form of log. Now I have come up with a sum so that I can explain you the application of the formulas which we have done of writing in the exponential form, then converting it into the logarithmic form. So that if I explain how we make use of it when and where, things will become clear to you. So we have a question here where it is given that log x to the base 10 is a, log y to the base 10 is b, and log z to the base 10 is c. We are asked to find the value of 10 to the power 3a plus 2 in terms of x, then 10 to the power, we write down 10 to the power 4b minus 3 in terms of y, and if log p to the base 10 is given the value as 4a plus b by 3 minus 2c, then to express p in terms of x, y, z. So we need to start with the given part which is given in log, convert it into the exponential form because we are requiring in exponential forms. So writing the first one, log x to the base 10 is equals to a. So 10 to the power this a will become x. Then taking with the second one, log y to the base 10 is equals to b. So I will get 10 to the power b is equals to y. And the last one given to us is log z to the base 10 is equals to c. So I will get 10 to the power c is equals to z. So we know the expression in terms of exponential form. Now if I take the first one, which is 10 to the power 3a plus 2. So now 10 has a power in addition. You know that when it is in addition in the exponential form, we write with the same base separated, then it gets multiplied. So this will get written as 10 to the power 3a into 10 to the power of 2. Now 10 to the power 3a, I know the value of 10 to the power a. So 10 to the power 3a, because the powers are multiplied, I can write it with one power over the other power, 10 to the power a to the power 3, and 10 square can be written as 100. So I will write this one now 100. 10 to the power a value is x, so written x, and this power 3 written. So it means now 10 to the power 3a plus 2 is same as 100x cube. Okay. Now I will take a look into the second part. In the second part, it is given to me here 10 to the power 4b minus 3. So 10 to the power 4b minus 3. In the previous one, at this place it was addition, so we multiplied with the same base, and then here it is subtracted, so it will be divided. So I will be writing here 10 to the power 4b by 10 to the power 3. Now 10 to the power 4b value I don't know. I know the value of 10 to the power b. So I will write it as 10 to the power b to the power 4 by 1000. Now 10 to the power b will be written as y. So it becomes y to the power 4. Y to the power 4 by 1000. It means 10 to the power 4b minus 3 is y to the power 4 by 1000. Now let us come to the third part. Like this part, log p to the base 10. Log p to the base 10 is equal to 4a minus b by 3 plus b by 3 minus 2c. Now we have been asked to express here p in terms of x, y, z. So I will change from log to the exponential form. So I will get 10 to the power 4a plus b by 3 minus 2c. Now there is a combination of both plus as well as minus, and this I should write it equal to p. So now I will be writing that p in the beginning. That looks better. And this one I will split it up now. 10 to the power 4a into, it is plus, so multiply 10 to the power b by 3, it is minus, so divided by 10 to the power 2c. Now I will bring it in the way it is the values I know. So 10 to the power 4a, I will write 10 to the power 8 power 4, then 10 to the power b power 1 by 3 because it is b by 3, and then 10 to the power c to the power 2. 10 to the power a is x, so x to the power 4 into 10 to the power b is y, so y to the power 1 by 3 by 10 to the power c is z, so z square. So I have now p equals to this, so this is my answer for the third one. So you have learned to relate when it is given directly in exponential form, how to find it, and if it was in the third one like given in log, so converted in exponential forms, it becomes again similar to the first and second part, and substitute the values for which we were knowing it. I hope you have learned how to apply the exponential and the logarithmic form to solve this sum. So I have come up with another sum where again we will see how to apply the concepts of exponent and log which we have studied. The question goes like this: if log y to the base 2 is equals to a and log z to the base 3 is equals to also a, we need to find the value for 72 to the power 3a minus 1. So first of all, what is given to us, let us convert that into the exponential form, because whose value we have to find is there in exponential form. So we write this log y to the base 2 is equals to a. So I get 2 to the power a equals to y. And with the next one, log z to the base 3 is equals to a. So 3 to the power a equals to z. So we are ready with the exponential values. Now we can write whose value we have to find, that is 72 to the power 3a minus 1. So this I can go to write as 72 to the power 3a by 72 to the power 1, which is not necessary to be written. Now this 72 you know is 8 into 9. Why I am talking about 8 into 9? Because we know the values where the base is 2 and 3. So 8 can be written as 2 to the power 3. 8 into 9, 9 can be written as 3 to the power 2 to the power 3a by 72. 2 to the power 3 to the power 3a, power over the power gets multiplied. So I get 9a and 2 into 3a will give me 6a by 72. Now I know the value for 2 to the power a, so I will write it as 2 to the power a power 9 into 3 to the power a power 6 by 72. Now here 2 to the power a can be substituted as y. So y to the power 9 into 3 to the power a can be substituted as z, 6 by 72. So this is my answer. So you have again learn further how to apply it. This you practice the sums, take your textbook, work out the sums from there, apply the concept which I have explained, you will be able to cover up all the sums. This is the first part of logarithm I have done. I will be coming up with another video of logarithm, the second part of it, which will contain the properties of logarithms when it is in multiplication form, when in division form and power form, how to relate them and solve. That will include a little bit more than what we have studied, but in that second part also you will require the use of these. Okay, these are the basic things we have started, which will get used again and again. If you have liked this video, kindly like it, subscribe it and share it with others. Thank you for watching the video completely.